factoring expressions. I know we did this in class already, but it is always useful, I think, just to get a quick recap of what we did, especially if you were struggling with the homework or just need to see it again for studying purposes. So we're just going to look at it really quick, couple examples, that's it. First off, GCF, just remind yourself, what is it? GCF, talking about the greatest common factor, which in class we defined it with words. It's the greatest or the biggest number that can divide evenly into two or more numbers. We worked on finding the GCF, and then we started to apply that to our algebraic unit and breaking down an algebraic expression. So let's look at two examples. That's it. One thing I really want to point out before we do anything are what the directions say, because sometimes you get to a problem and you're like, I know how to do it, but I didn't know that's what it was asking me to do. So pay attention to what it's asking you. You might see this. Use the GCF to write an equivalent expression. Okay, that's one way you might see this, and that's pretty self-explanatory. But another way that this might be worded is it might say to factor the expression. Factoring the expression means you're taking out the greatest common factor from any of your terms, and let's look at what that means right now. So we've got the expression 42 minus 7a. There's two terms. Let's find the GCF and rewrite an equivalent expression, also known as factoring the expression. So this is a fairly easy one. I've got the two numbers in case you forget. 42 and 7. What are their factors? Well, there's only one that they share other than 1, and that's 7. 7 can go into 42 6 times, and it can go into 7 1 time. So your GCF for these two numbers, the biggest number that can go into both of them is 7. And now let's factor this expression. I'm going to take out the greatest common factor from both of these terms, and that leaves me with 6, because 7 times 6 is 42. If I'm taking out a factor, I'm taking out of one of the numbers that when I multiply it together results in this original number. So 7 times 6 is 42. And if I factor out a 7 from 7, that leaves me with 1. So you could have this written as 7 times 6 minus 1a. Some people like to write it as 7 times 6 minus a. Both are correct. This one actually, the second thing I wrote, is probably a little more common to see. We don't always see the coefficient 1 in front of a variable, but both are acceptable and both work. Let's look at just one more. If you can do two of these, you can do all of them. You just got to practice. So just one more worked out for you in case you need to see it using some smaller numbers. Pause it if you want to try it yourself. Let's see. The GCF of 27 and 18. What's the biggest number that can go into both of them? Well, I could, and I know some of you would see this right away, but I'm going to do it in two chunks. I see that both of them can be divided by 3. 27 divided by 3, 9. 18 divided by 3, 6. Both of these can also be divided by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. If I multiply together both of the factors, both of the numbers I divided by, I divided by 3, I divided by 3. That will give me my GCF, which is 9. And that's important because that's what I'm going to factor out of the two terms here. So I'm going to take out the 9 from the 27, leaving me with 3, and the variable just stays. And if I factor out a 9 from the 18, that leaves me with a 2, and the variable just stays. And the way you can check is just redistribute. So 9 times 3 is 27x, 9 times 2 is 18y. I've got two equivalent expressions, and all I did was I factored out the greatest common factor. If you can do these two, you can do all of them. So keep practicing. If you want extra problems, let me know. You can always use IXL, 10 marks, but keep practicing, do your best.